Hope you all are doing good. So welcome to the system design day 4, and we are continuing with our scaling pattern, and today we are going to touch base on the two scaling pattern which is related to the database. So first is database sharding and second is replication. With that mentioned, let's get started. So what is database sharding? So before that, let's take a simple example. Let's say we have one database and with that we have one table, and that one table has 10,000 records. Okay. Now, as you know, more and more the records are coming, the writes are happening, more insertion are happening, more data is getting inserted. It is very hard to handle. Okay. So what if instead of storing the 10,000 records in one database, if that database is splitted across multiple databases? Okay, let's say it is 10,000 records. The first 1,000 record is on one database, second 1,000 record is on the second database, third 1,000 record is in the third database, as you see in the image. So this is called database sharding. So these pieces are called shards. So let's call shards is nothing but pieces of the actual database. Okay, so here what we see is a table has, let's say, 4 columns. Okay, and after 1,000 records, next records is stored in a separate database, next records are stored in a separate database. So we are actually cutting the tables horizontally. Okay, and the next pieces we are keeping it in different shards, or we can say different piece or the continuation of this database. This is called horizontal scaling, because the more you add to the new shards, new databases, it's increasing more and more as and when required as per our requirement. So this is called horizontal scaling. Now why are we doing in this manner? Okay, so imagine you want to access some xyz number of record. Let's say you want to access the 12th record. Okay, so 12th is just an example. So to traverse, okay, we definitely have indexing, primary key, secondary keys, but 12 is just an example. Let's say 12 lakh record. Okay, that if you want to traverse, it will take some time. Okay, so doing the reads, doing the writes, doing the operations on top of the data, or adding more data to the same big chunk is very much difficult. That's why horizontal scaling is helping us in this. Okay, so let's take an example where we are using this database sharding, that is horizontal scaling. And now if there is a new data coming, okay, or any operation needs to be performed. So previously, if you can see, the client is using the application, and to perform an xyz operation it is taking 100 milliseconds. But now when the client is using database sharding, that is horizontal scaling, now the same operations can be performed in the 20 milliseconds. So here the response time, the latency is drastically improved with the database sharding. Here when we are saying that a record should go to shard 1, shard 2, shard 3, or is there a requirement of creating more shards, it all depends on the routing mechanism. Okay, what is the algorithm that we are using for routing? Based on that, all these decisions will be taken about which record should go to which shard, or is there a requirement of creating a new shard. So this routing is handled over to the shard manager. Now shard manager will be doing data partitioning, and with the help of one of the routing algorithm, it will make sure which record goes to where, so that even when performing the read, it knows where to redirect the request. Okay, so what are the different types of this partitioning? We have range based partitioning, hash based partitioning, list based partitioning. So of course, by name itself, range based partitioning, you are able to understand. Let's say we want to have only 100 records in a shard, so once 100 records are done, 101 record should go to the second shard. Okay, similarly hash based and list based. So we are going to deep dive more into these routing techniques, but as of now, the only takeaway is that based on routing mechanism, the sharding manager will do the partitioning and redirect the request to the corresponding shards. With that mentioned, let's move on to the next scenario where the horizontal scaling, that is database sharding, is helping us. So in one database, the scenario in which we have one database, if the database is crashed, the failover needs to be done for the complete database. And of course, whatever we are doing is to avoid the downtime, the first thing. And second thing here, more focused is that there is more risk, since we have our complete database is crashed because it was one piece, and now we have to do failover for the complete database. Okay, but in case where the sharding is there, if the database is crashed, it is definitely crashed means one shard is crashed. Okay, first, second, third, let's say we have 3 shards. the second shard is crashed. So in our case, instead of doing the failover for the complete database, we need to do failover only for the shard that is crashed. So for example, we have three shards, second shard is crashed, so we need to do failover only for the second shard. So that's how even the service outage can be avoided. It can be avoided when it was one database itself, but in this scenario the risk is less and the efficiently with which the failover can be done is increased. Okay, now let's spend a few minutes more in understanding what shard is. So far we have understood that shard is nothing but a small piece of the database. Okay, now how does it look like? Okay, so when we say a computer, a server, a node, we call it as physical shards. Okay, so let's say I have 5 systems. Okay, now my application, I can have database shards on all the 5 systems. Okay, so this is called one shard on one node. So here in this scenario, I can say that I have 5 logical shards, that is my actual databases, on 5 different systems, that is 5 different shards. A physical shard, that is a system or a node or a server, can have multiple logical shards, that is the databases. Because let's say for example this first system where I have stored my first shard, similarly other applications 10th shard can be also on the same server. Okay, or my 10th shard itself I can put on the first server node. So that's where we say that a physical shard can have multiple logical shards. Physical shards is nothing but a nodes, and logical shards are nothing but our pieces of databases. Okay, so we can see the client or the application has nothing to do with what is happening behind the scene. It's all under the abstraction layer. Client will simply use the application will redirect to the server will call to the software layer, and software layer will make sure where to redirect the request, where to redirect the request in the sense to which shard of the database. So with that mentioned, let's move on to our second topic, which is replication. Now the second technique, database replication, where replication simply means copying. Now the second technique, database replication, where replication means simply copying. So we have main database, which we call it as a leader. Now then we have a replicated DB, which is nothing but a database on which the leader or the main database actually the copies the original data into the other databases, which is simply a replicated database. Now this can be many, so it can be 1 2 3 anything, but it is preferred to have it in the odd numbers and to have at least more than 2. Now there is a logical reasoning behind it, but for now let's stick to the topic. Okay, so we have a leader database, we have replicated databases. Now first question, why do we need to have a replication enable, or basically why we need to have a copy of a database at any point of time? The reason is, first, protection against the data loss. Second, improves the latency. For example, there is a request coming which only wants to read the data. So instead of redirecting that request to the main database or the leader database, if you can simply redirect that request to the replicated database, the actual main database which is handling the write operations, the performance wise it will not get impacted. So that is just one example of improving the latency of the database with having the request redirected to the replicated database. Now the third is application scaling. Now all these techniques that we are dealing in the database replications are applicable for the application server and for the object file store and for the cache purpose as well. So it seems straightforward, right? Then why do we have such big content or length or topics in the database replication is about only one point. Now what is that one point? Let's say when the leader is crashed or not available, automatically the failover should happen and one of the replicated database should take the role of the leader database. So when we say take the role of a leader database, means this is going to be the main database now onwards that is going to handle all the write requests as well. Now for someone to become the leader, it should have the exact data that the leader was having and consistent. Okay, what are the qualities of a replicated database to become the leader database? One is it should have the exact consistent data and it should have similar infra that the leader was having, so that when the write request is redirected to this newly created leader database or newly formed leader database, should not be any differ than that of previously the leader database that we were having. So only because of this reason we have so many types and categories for the failovers and for deciding who is going to become the leader among the multiple replicated databases that we are having. Okay, and how the recovery is going to happen and how all such things are going to be intact even after leader database is crashing. Okay, so we are going to start with few of them. One is leader follower strategy, where we are going to have one leader and then how the request is being replicated across the replicated database. For that we are going to have a synchronous leader follower replica, and the second one is asynchronous leader follower replica. Okay, now first let's see what is synchronous leader follower replica. Here what happens is, if you can see, a client made a write request to the leader, and write request that leader received, it forwarded to a replicated replica, or we can say first replica, and it also forwarded to the second replica. Now it is waiting. Okay, it is not simply giving the response to the client, it is waiting for the acknowledgement from the first replica, and it is waiting for the replica for the acknowledgement from the second replica. So once it received the acknowledgement from all the replicas that is available at that point of time, it then acknowledges to the customer, okay, or the application or the client that from which it got the request. Now consider a scenario. What happened here? Everything was successful, but because our leader database was waiting for acknowledgement for all the replication database, the latency got affected, so the delay was there. Agree? Now consider, this was a happy path. Though it was a happy path, latency was there, but at least we can say the data is consistent across all the leader and replicated database. Now second thing, consider a failure scenarios. Let's say the request went to the replica 1 and it gave the acknowledgement. The request went to replica 2, but the acknowledgement failed because let's say replica 2 was crashed or for some reason. Okay, acknowledgement failed. Now because of this failure, though it received acknowledgement from other replica database, because at least one replica database was there which did not do the acknowledgement, the whole write request got failed. Okay, so this is this has to be done because it is synchronous, means everything will follow a pattern. If something is breaking in the pattern, the complete flow is like a transaction. If there is something breaken, in our case the acknowledgement from the second replica, complete request or the complete process got failed. Okay, now with this what we can assure that consistency is there, but it is going to impact the failover and latency. Okay, now with that mentioned, let's try to understand how the process is different in the asynchronous leader follower replica. So the similar case, if we take, the client requested a write request to the leader database. Leader database, it forwarded the request to the replica 1 and replica 2. Okay, but now the leader is not going to wait for the acknowledgement. It is going to simply acknowledge to the client that okay, I have received your write request and the operation is done. Now whether the acknowledgement is coming from the replica 1 or replica 2, if it is coming, well and good. If it is not coming, still it is not considered as failure. With this, the benefit that we are having is the latency is very good. Okay, the operation that is performed is very good because there is no waiting period as we have seen in the synchronous leader follower. Okay, but here the issue is with the consistency. Now we cannot assure consistency because the leader database was not waiting for the acknowledgement. You agree? Now here in the asynchronous or synchronous leader follower replica that we are seeing here, the issue is one, the synchronous has the issue with the latency, asynchronous has the issue with the consistency. But the common problem in both of them is a failover. So failover can be done in both of them, but both of them gives the challenges. That's why we consider failover is possible, but it is problematic. So what is the solution here? Okay, one thing, failover is possible in both. Okay, with of course a trade-off of latency in the synchronous, trade-off of consistency in the asynchronous. But what is the solution? The solution is leader or that, or we call it as multi-leader replication as well, or we can go for the leaderless replication as well. So let's spend a minute on what is leader or multi-leader replication is. So in the leader or multi-leader, what is happening is, instead of one leader that we have seen in the leader follow strategy, here we will be having multiple leaders. Okay, and how the new leaders will be decided is based on the consensus algorithm. For example, Paxos. Okay, Paxos, my bad. So now, what are these algorithms and how the new leaders are decided in the multi-leader replication algorithms, we are going to see in the coming videos. Okay, now second thing is leaderless replication. So by the name itself, we can say there is no leader in this leaderless application. The reason being, if the election thing is a problem, okay, and if the conflict resolution is a problem, then why to have it in the first place? So the solution is leaderless replication. So we are going to see what are these two things in the coming demonstration. So as of today's video, if there is anything that you want me to focus on more, or if there is anything which is explained but you did not understood, do mention that in the comment section, and let's have a fruitful discussion in the comment. With that mention, we are at the end of day 4 of system design. Let's continue with more, and let me know if you have any queries in the comment section. Thank you.